Imagine you are sitting in seat 14A, 38,000 feet above the Atlantic. You are sipping a ginger ale, watching a movie, and feeling perfectly secure in the millions of dollars of engineering surrounding you. But what if I told you that right now, several critical components of this aircraft are technically broken? I am not talking about a cracked plastic tray table or a reading light that won't turn on. I am talking about systems that help the plane stop, stay cool, or even navigate through the clouds. And here is the truly wild part. The pilots know about it, the mechanics know about it, and the government says it is perfectly legal. Welcome to the world of the Minimum Equipment List, or the MEL. It is the most important book in aviation that you have never heard of, and it is the reason your flight isn't canceled every single time a sensor glitches. In the next few minutes, we're going to pull back the curtain on the 5 specific things that are likely broken on your plane right now, how pilots manage the risk, and why the line between a broken plane and a safe plane is much thinner than you think. Before we get into the heavy hardware, you need to understand how a plane is allowed to leave the gate with parts missing. Every commercial aircraft has a master minimum equipment list issued by the manufacturer and approved by aviation authorities like the FAA or EASA. From this, each airline creates its own specific MEL. This book is essentially a legal document that says you can fly with item X provided you follow procedure Y. If a part breaks and it is not in this book, the plane is grounded, period. But if it is in the book, it gets an inoperative sticker, a logbook entry, and a ticking clock for when it must be fixed. Now, let's look at the first thing that is probably broken on your aircraft, the Auxiliary Power Unit, or the APU. If you have ever walked down the jet bridge and heard a loud, high-pitched whining noise coming from the tail of the plane, that is the APU. It's a small jet engine buried in the back that provides electricity and air conditioning while the main engines are off. It also provides the high-pressure air needed to start those massive main engines. On many flights, the APU is deferred, meaning it is broken and waiting for parts. Is it safe? Yes, but it makes the pilot's lives a lot harder. Without an APU, the plane is essentially a giant brick until it is plugged in to ground power. If the pilots lose both engines in flight, the APU is supposed to be the backup generator to keep the cockpit screens alive. When it's broken, they are relying entirely on batteries or a tiny deployable windmill called a ram air turbine. Flying without an APU is legal, but it means the pilots have a much smaller margin for error if things go south. It's like driving a car with a dead battery. As long as the alternator is running, you're fine. But if you stall at a red light, you're in trouble. This brings us to the second item, which is much more common than you'd think, one of the air conditioning packs. You might think the packs just keep the cabin at a comfortable 72 degrees, but their primary job is much more vital. They provide the pressurized air that allows you to breathe at high altitudes. Most airliners have 2 packs for redundancy. It's perfectly legal to fly with one of them completely broken. However, this comes with a massive catch. If you only have one functioning pack, the plane usually cannot fly at its maximum altitude. The pilots might be restricted to 25,000 feet instead of 41,000. Why? Because if that one remaining pack fails, the cabin will depressurize so fast that the pilots need to be at an altitude where they can descend to breathable air before everyone loses consciousness. So if you ever notice your flight is taking much longer than usual or flying much lower than the other planes on the tracking app, there's a good chance one of those packs is sitting in the hangar's back room. Now let's talk about something that affects how the plane actually moves, the auto-throttle. In a modern Boeing or Airbus, the pilots rarely move the thrust levers by hand during the cruise. They set a speed, and the computer adjusts the engines to maintain it perfectly. It's incredibly precise and reduces pilot fatigue. But the auto-throttle is a complex system of motors and sensors, and it breaks all the time. When it does, the pilots have to fly manually. This doesn't mean they are sweating and struggling, but it does mean they have to constantly monitor their airspeed and adjust the power themselves for hours on end. In the aviation world, we call this a high workload environment. It's legal to fly like this for up to 10 days under most MELs, but it means the pilots are much more likely to be tired by the time they reach the landing phase. It's one of those invisible failures that passengers never notice, but it significantly changes the dynamic in the cockpit. If you have ever felt the engine surging or dipping slightly during your flight, that might be a pilot manually hunting for the right power setting because their computer assistant is on strike. This leads us to our fourth item, and this one is a bit more nerve-wracking, the anti-skid system. Think of this as the ABS on your car. When a massive jet lands at 150 miles per hour, the brakes have to work incredibly hard to stop hundreds of tons of metal.
If the wheels lock up, the tires will explode within seconds. Most planes have multiple anti-skid channels, and it's often legal to fly with one or more of them inoperative. However, this is where the math gets intense. The pilots have to go into their performance laptops and calculate exactly how much extra runway they need. If the runway is wet or icy, a broken anti-skid system might mean the plane is legally barred from landing there. But if the runway is long and dry, the plane can take off with a broken brake controller and simply use more of the tarmac to slow down. It's a calculated risk managed by strict numbers, but it means the plane is landing with one hand tied behind its back. Finally, we reach the fifth and perhaps most surprising item, the TCAS, or the Traffic Collision Avoidance System. This is the system that talks to other planes and tells the pilots to climb or descend if they are on a collision course. It's the ultimate safety net. You would think that a plane would be grounded immediately if its collision avoidance system failed, but under certain conditions, it's actually legal to fly without it for a short period. If the TCAS is broken, the pilots have to rely on their eyes and the instructions of air traffic control. This is known as see and avoid. While ATC is great at their jobs, the TCAS is there to catch the human errors that inevitably happen. Flying without it is like driving a car without blind spot monitors. You can do it safely, but you have to be much more vigilant. Often, when a TCAS is deferred, the plane is restricted from certain busy airspaces or required to fly at specific altitudes where traffic is lighter. It's a fascinating example of how aviation safety isn't about having a perfect machine, but about having enough layers of protection that even when one layer is missing, the others can catch you. You might be wondering, why not just fix everything immediately? The answer is a mix of logistics and economics. A part for a Boeing 787 might not be sitting in a warehouse in Des Moines or Lisbon. It might be across the ocean. If airlines grounded every plane for every minor sensor failure, global travel would grind to a halt. The MEL system allows the global economy to keep moving, while ensuring that the missing part is compensated for by other safety procedures. For every broken item, there is a corresponding operational procedure. If the landing lights are broken, the plane only flies during the day. If the fuel gauge is inaccurate, the mechanics use physical dripsticks to manually measure the fuel before every takeoff. It's a system built on the reality of mechanical wear and tear. So the next time you see a piece of silver tape on the wing, which, by the way, is high-speed aluminum tape and perfectly legal for temporary repairs, or you see a mechanic putting a small sticker on a cockpit instrument, don't panic. It means the system is working. It means the failure has been identified, logged, and checked against a century of safety data. Your plane might be broken, but it's also one of the most heavily scrutinized machines on the planet. Aviation isn't safe because nothing ever breaks. It's safe because we have a plan for when it does. If you found this dive into the secret world of aviation maintenance interesting, make sure to hit the subscribe button and turn on notifications. We have a lot more coming on the hidden mechanics of the sky. Until next time, keep your eyes on the horizon and enjoy your flight, broken parts and all.